here. Get rid of that. And go back. Using the mouse is weird. Okay. All right, cool. And then go back over here. All right, we're ready to go.
Okay, I'll do 30 seconds.
Okay.
Explaining the thing.
Sure. All right. Nope. Okay. Can everybody see the slides that says online creative collaborative content generation? Cool. And then if I go to the next slide, does it say Thesis Committee at the top?
Yes.
Excellent. Okay. There you go.
Right. Okay, welcome everyone. Very happy to see so many people here. And I'm very, very excited that we have Charity presenting their PhD thesis. So the way this is going to go is that M will present her thesis and the research for about 45 minutes or so. And then we will open the floor for questions from the audience. A reasonable number of questions from the audience. After that, we will have send all of you out, and it will just be M and the committee. The committee consists of Wesley, Kerr. Oh, you present the yeah, you'll present. Yeah, well, the M will present the committee, and those of you who want to stay on and wait will wait down in the Game Innovation Lab on the 6th floor, and there are several people here who can take you there. And when we're all finished, there will be a reception at the Game Innovation Lab. Party, right. So I'm Julian Togelius. I'm the main advisor, and I'm very much looking forward to this. So,
Thank you. Okay.
Take it away.
All right. Thanks, everybody. Yes, recording is on. All right. Let's get started with this. Thank you all for coming. I'm so excited to do this. It's been kind of 8 years in the running. I'm kind of terrified, but you know what? Let's just go into it. So my name is Charity. I am a PhD student at the Game Innovation Lab, and I will be talking today about online creative collaborative content generation. What is that? And I'll tell you. So for the lovely thesis committee that I have here today, we have Dr. Julian Togelius, who is the committee chair and thesis advisor and associate professor of computer science at NYU. We have Dr. Michael Cook, who is a senior lecturer of computer science at King's College London. We have Dr. Kate Compton, who is director of play at LEGO. We have Dr. Antonius Liapis, who is a senior lecturer at University of Malta. And we have Dr. Wesley Kerr, who is head of tech research at Riot Games. So you're probably wondering why I brought you all here today. Just to get started with my why I wanted to do a PhD in the first place. It started a very, very long time ago when I was making Legos when I was 12 years old. I was making little Lego like stop motion animation videos, and I really like to combine characters from different sets. So in this example, SpongeBob and Stormtroopers and Darth Vader. And I really like that I can make my own stories by using these characters that I know so well from movies and TV shows. When I was a kid, I also talked a lot with Cleverbot, which was this chatbot that kind of emulated talking like a real person. So a lot of people were thinking, I'm just talking to another human. It was that good. But in reality, it was just a bot that would learn from other human interactions that it would have with it, just to emulate different sentences just really, really well given the context. When I was a kid, I also really wanted to get into game design, hence why I'm doing a PhD in game design. And one of the first engines that I learned to program and make games in was Scratch. And I really like Scratch because it not only lets you do this drag and drop system for programming, but it allowed you to create games and post them online. And then you could look underneath the hood at other people's games to see how it worked. So you could learn to get become a better programmer and better game designer from other people. And then lastly, my favorite game growing up was Little Big Planet. And similarly to Scratch, you could design your own games and design your own levels in the game itself and then share it online. But you could also design it with friends, like in your own like little moon world. And this game had a lot of options for like also programming with like logic gates, and you could build your own levels and platforming games. You can change the genre of the game entirely. So it was a really beautiful framework for just like collaboration and sharing online with people. So moving on from my childhood, we've seen a lot of AI today. The AI that you may have seen in your daily life can include roguelike games. So these are games where there's procedural content generation. I'll talk a little bit about that later in the background section. But in a sense, everything in the game is made by the AI beforehand. And so you have a different experience every single time you play it. So in this case, this is the game Splunky, and the levels are generated in, every time you load up the game. And nothing is ever the same. The enemies are never placed in the same place. The gold and the treasure that you can get is never the same. So you kind of have to adapt to what the AI has generated for you. We've also seen some AI in form of recommendation systems. So these are some examples taken from my phone with the autocorrect fixing my terrible typing, and also from my TikTok feed with a lot of animations and cartoons and video games. And these are all things that I really like. And the TikTok really is good at trying to keep your attention and feed you the same content that you're interested in. So it's one of fantastic recommendation system. We've also seen some things recently with text-to-image generation. So you may have heard of DALL-E 3 or Stable Diffusion or Bing's image generator. And these are really quick and interactive content generation tools where you can make new images just from a single sentence in a couple seconds. It's very cool. So this is an example of a PhD thesis invite that I made in the Bing image generator. And then lastly, I think a lot of us in this room have heard of ChatGPT or used it in some form. So this is almost like next level of Cleverbot, where you can ask it whatever you want, and it will come up with some kind of answer that may or may not be right, but it does sound pretty accurate. It's so general and it's very interactive. It can come up with almost any answer you have to any question. So what makes these systems so popular and so useful in the first place? Well, they're online and anybody can use them. You can play it in your video game. You can use it on your phone. You can use it in your browser. So this accessibility is something that I want to study and focus on with my PhD. How do we make AI more accessible that anybody can use it? You don't have to be a computer scientist. You don't have to have a PhD. How do you use AI to help you? So the research questions that I will be addressing in this PhD thesis today are, how do we combine AI tools with game design in particular, because I like video games? How do we bring users together to create content with the help of AI? Can AI make us better creative designers? And in turn, can we teach AI to be more creative? And then how do we make AI more accessible to people? Oh, sorry, it's not showing up. Okay, there, yeah. And how do we improve communication between designers and AI? So my thesis statement for this 5 years of my PhD is this. When applied to creative domains, online systems allow users to more effectively design, share, and evaluate content with AI tools. And these are the 4 contributions that the works that I will talk about in the next 40 minutes of this presentation will cover to contribute to this thesis statement. So here's the outline of the 10 projects that I worked on and we'll be talking about in the next 40 minutes. It's a lot. Just to break down each of the projects and how they contribute to the thesis statement. The first 2 with the Mech-Elites and Amorphous Fortress are more of lead-in work. They help kind of give context to the other 2 projects, which is Baba's Y'all, Amorphous Fortress Online, whose contribution is collaboratively generating diverse game content online. The other 2 projects are the Aesthetic Bot and Minecraft Interactive Evolver, which is to contribute to designing online systems for open-ended environments and problems. Next 3 are for the Keke AI Competition and the $5 model, which is for utilizing online data to further AI research. And finally, with the Abstract Game Recommender and Generator and the Ink Splotch project is for gathering feedback from designers for use in future AI-assisted tool development. This is the order that I'll be talking about these projects in. It looks very confusing right now, but it'll make sense in the context, don't worry. Just a note on the rest of the presentation, the project sprite for the project I'll be talking about will always be in the top right corner. All the images and diagrams for the slide will be in the middle. It's usually animated. And then the takeaway message will always be in bold at the bottom, and the paper citation will be at the very, very bottom in a light gray. Okay, so before we dive into this, I need to give some background information to talk about the related projects and the contexts that they're used in. So procedural content generation, I mentioned that before in the use of roguelikes for like Splunky. So procedural content generation, or PCG, is the algorithmic creation of game content with limited or indirect user input. So what kind of content? It can include spaceships or nice flowers or assets that you might need to put into your game. But it can also include the entire levels themselves, such as what I mentioned in Splunky, but also roguelikes from the roguelike game of NetHack. This can also include the entire world, such as in Minecraft, where it will generate a 3D environment for you. Procedural content generation can also be applied to more meta things, such as in dialogue or character traits for your NPCs, or entire video games themselves can be procedurally generated by AI. So there's another form of procedural content generation called mixed initiative content creation. And this allows both humans and AI to have agency in the content creation process. So examples like this can include for level design with the AI system providing suggestions for the edits. So this is example applied to Sentient Sketchbook, Load Encoder, and the Ropossum, which is the Cut the Rope clone. There's also RO Brush, Pataco, and an image-to-image mix initiative editor where you can draw lines and it will fill in the blanks for you. So with this mix initiative process, it allows the user and the design and the AI to kind of take turns with the editing process. And a lot of the projects that I'll be talking about in this presentation will discuss how to find a balance between human AI collaboration for content creation. And finally, I will be talking a lot about the process of evolution. And this is a form of content creation that allows a system to generate multiple samples at once that are evaluated and guided toward a central goal. So these samples are usually modified or mutated slightly by shifting components of them. So for example, in this is called Boxcar 2D, and the AI will generate a bunch of different cars that have a lot of different properties. So you can change the wheel size and the body shape itself. So these cars are evolved to make cars that can go further and further along this generated terrain just by modifying the wheels and the actual vertices of the body. There's also the aesthetic bot, which I will talk about later in the different projects, where you can see an entire population of maps being evolved and changed ever so slightly by shifting the tiles to make a more aesthetically pleasing map. To figure out which samples get to stay and be mutated for the next generation, there is a selection process. And there's a form of the selection process called interactive evolution, where the human can go in and pick which samples they actually want to continue in the next generation. So this example is from Pick Breeder, where you can pick which images you really like the best. The AI will evolve it, mutate it slightly to make images that are slightly the same, but a little bit better than what you originally had. There's also another form of evolution called Mech-Elites, and this is to maintain different sets and different characteristics of elements, and not just have one central goal. So in this example, this is for Evolutionary Dungeon Designer. It's also a mixed initiative tool where it will allow the user to pick a different map based on characteristics such as how many enemies do you want? How many wall tiles do you want? How long does it take to actually solve and get to the end of the goal? Stuff like that. So we're going to be talking a lot about the procedural content generation, mixed initiative systems, and evolution in the following projects. So coming off of evolution and Mech-Elites, the first project that started this whole PhD is the Mech-Elites project. So in video games, you typically have a tutorial level, and this is to teach you how to play the game with the different mechanics. So for example, in Cuphead's tutorial, it shows all the mechanics at once with the controls. You can jump, you can dash, you can shoot. Mario is a little bit more implicit with its mechanics, so it lets the player learn for themselves how to play the game. So you have to run to the right, hit a mystery block, and stomp on a Goomba. So can we take the most important mechanics from each game, such as the jump, dash, and shoot from Cuphead, and the running to the right, hitting the mystery block, and stomping the Goomba, the critical mechanics necessary to actually beat the game, and put it into an AI so that it can automatically generate tutorials for us using different combinations of mechanics. So you have a tutorial level that teaches you how to jump and teaches you how to jump and dash, et cetera, et cetera. So the Mech-Elite system using evolution takes a list of mechanics. Say we have the getting the key, killing the enemy. Takes a randomly generated level with some of these elements already included in the map. So key, enemies already there, a bunch of other stuff you really don't need. Using evolution, it will try to make a very minimalist tutorial level from this randomized level and also maintain different sets of tutorials based on mechanic lists. So in this example over here, you have the archive that has a level with no enemy, no key, a key, one enemy, and both an enemy and a key. And each level will show some different combination of the critical mechanics needed to beat this game. So for this system, we tested it on the GVG AI framework, which is a general video game AI framework. It has a lot of different games with a lot of different genres and a lot of different mechanics. For the sake of this experiment, we did for 4 games: Zelda, Plants, Solar Fox, and Real Portals. And each of these games has their own set of critical mechanics necessary to beat them. This is the different number. They're mostly 10, except for Real Portals, which has a whopping 35 mechanics in it. So we're going to try to generate tutorial levels for all 4 of those games. And in this experiment, it was successful at making tutorial levels that covered at least one of those mechanics that each game had. However, it wasn't able to make all the combinations of possible mechanics. It covered about less than 25%. So how do we find these missing tutorial levels where we need a very specific mechanic combination? Well, this is where human AI collaboration can really come in handy. So leading into the next project, where we tried to solve this original limitation with the level mechanic combination, but this project ended up being something much bigger that kind of fueled the rest of my PhD. So to find the missing levels from the users, let's take concepts from crowdsourcing, such as in Wikipedia. We can take concepts from Super Mario Maker, which allows users to design their own levels using a well-known and well-established game framework, such as Mario. We can also take the Mech-Elites quality diversity algorithm to make sure that users are designing different types of levels, not just making like a level where you can jump and only jump. And with this combination, we can have a diverse set of mixed authorship levels, levels that are made by both humans, AI, and humans and AI together, but also have a wide range of different mechanic combinations. So the system was applied to the game Baba Is You. Now, Baba Is You is a puzzle game where you have to push the blocks in order to break rules and solve the puzzle. It's very similar to a game called Sokoban. So in this example with the GIF, the wall is stop rules in place and the player cannot move past the wall. So the player has to move one of the rules out, or one of the words out, to get to the wall and break the rule. So with this game as the baseline for this system, we designed a level editor and a website where people could go and edit and make their own Baba Is You games. However, unlike Super Mario Maker, where you can just go in and make whatever kind of level you want for the game, this has an AI system in the back end that will help you design the level and optimize it towards getting new and diverse levels with different mechanics. So because of this, we had a whole set of different levels, from only user-made Baba Is You levels, PCG or AI made Baba Is You levels, and then a mix of both human and AI combined made levels for Baba Is You. So the system was made up of a lot of different components. As I mentioned before, there's a main screen where you can go in, select which level you want to play. You can select based on how new it was, how well rated it was. And from there, you can also go and create your own map, either from something that already exists, so you can remix it, or just make it from scratch. There was also the rating screen, which allowed people to say, hey, I like this better. I like this level better than this level. I'll get into that a little bit later. It's a very awesome system. And then going from the main screen, you can go into the editor and actually place down the tiles or the elements of the game itself, or you can use the AI to allow it to modify it for you using evolution. You can set which objectives or which rules you want to see in the map itself to make it different from the other games. And then you can also use a highly rated level as a starting point to modify and add back into the database. From either of those screens, you as the player, of course, can go and play the levels for yourself in the browser. And you can either play it as a human, as you normally would for a video game, or you can get the AI to solve it for you. So the Baba Is You system has 3 different ways for evaluating map. First, with the AI solver or the human solver, just to make sure that the level is completely playable. For the user rating system, deciding whether or not level A is better than level B in terms of aesthetic quality, or if it's more challenging. And then finally, with the original evolution system that would evolve it towards having different types of mechanics. So we ran a user study on this project to see how people were actually interacting with the system. And we asked them, did you interact with this feature or this feature? This is a lot to look at right now, but I'll break it down into the other projects so it makes it much more concise of where the limitations are of the system. And what we found with people was that those that had never used AI-assisted level editors were more likely to actually make the levels themselves with no AI assistance. However, they were also the largest group to make it with AI assistance. So from this, we can infer that in the study and responses, users want to use AI tools, but this current system just had a couple of limitations of how to actually facilitate better collaboration. So this leads into the next couple of projects, the challenges that Baba Is You presented in human AI game content collaboration. So the first project I will talk about is the Keke AI Competition. So the first thing we tried to address was the AI solver. It's very good at solving levels that have a straightforward solution. You push the rock into the water and you can get across, no problem. And even with the user study, people tried to give the solver a chance, but for the most part, they ended up just solving the levels themselves. 100% of the users just solved a level with no AI assistance. So when it comes to more complicated levels that look like a hot mess, this is where the AI definitely struggles. It'll take sometimes 5 to 10 minutes just to try to come up with a solution and come up with nothing. Versus when a human tries to solve that same level, it's actually very simple. It only takes 7 steps and it was done in 10 seconds. So what's going wrong? The game itself of Baba Is You is a very complex game. You can break the rules just by moving around. So for an AI solver, that's a little complicated to do. So how do we fix this? Well, we get other people to make agents for us, hosting the AI competition for the Baba Is You framework. So people can design their own JavaScript agent and test them on the Baba Is You levels. However, these levels come directly from the Baba Is You site. So not only can you design a new agent, you can design new levels for your agent using Baba Is You, and then make even more complex levels for it to try to solve. So for this competition, we hosted a website where people could submit their own agent and have it compete against other agents, and also the solver that was already in place. And we had 4 different sets of levels that were meant to kind of trip up the AI solver. One called the precise level, which required very precise movements from the AI. Second one that was very meta-based and required the word blocks to actually be physically pushed in order to solve the level. A third one, which is just a maze, very easy for a human to solve, but a little bit harder for an AI. And the fourth one, which is from the same example I showed before with the very messy looking level space that was very complicated, but actually had a very simple solution. Sorry. And the best agents for this competition were ones that could solve it both quickly and as few moves as possible. So unfortunately, we only received about 3 submissions for the first year of this user competition. However, one team did get a solver that was better than the original solver that was in the website. So we've been also getting a lot of emails from people asking if they can have a Python version of this solver. So it is definitely a work in progress that people want to keep trying to solve these Baba's Yaw levels. Okay, next up is the second branch from the Baba's Yaw work, and one of my all-time favorites, the aesthetic bot system. So the second limitation of the Baba's Yaw site had to do with the aesthetic of the generated content. So if you take a human design level versus an AI design level, the human design is probably going to win most of the time because it just looks more concise and more intentional, and it looks pretty. This was also shown in the user study that most people just decided to design a level by hand rather than using the AI suggestions and the AI edits themselves. So the AI system relied on the user feedback from the rating system. So if not enough users were putting in these ratings, it can learn to make better levels in the first place. And this was also shown in the user study. Not a lot of people were interacting with this system to like tell it, this is a good looking level, this is a bad looking level. So how do we get people to play dozens, if not hundreds of levels? It's very exhausting as like, even for me, I designed the system. This is leading to a phenomenon called user fatigue, especially with mixed initiative systems like this. So how do we get users to rate a lot of different kinds of levels made by AI and look at a lot of content and say, this is good, this is bad, I like this, I don't like this? What is a platform that a lot of people use where they're going through a lot of content all at once and saying whether they like something? Twitter. Social media. So if we use Twitter to evaluate maps that are generated by AI, we can get better looking content without having a lot of user interaction. All they have to do is say, I like this, and move on with their day. So in this case, for the project, we had 2 separate types of levels. The first was the user-made level, similar to the Baba's Yaw site, where it's completely human edited. And then the second was the AI-made levels, where this was evolved to try to look better than what it could make. Both of these levels were fed into Twitter as a Twitter post, asking users, which one do you like better? Not at all disclosing which one was AI made or which one was user made. It's just asking, which one do you think looks better? And then users would vote in their Twitter feed. You could do it on your phone, which one you like better, go about your day. So the system for the aesthetic model starts off with this very, very tiny neural network called the aesthetic prediction model, or the APM. This will determine how aesthetically pleasing a map is without explicitly having something like, you have to measure how many grass tiles are in the map. So using evolution, it will evaluate a entire population of maps, similar to the GIF I showed before, saying this one is more aesthetically pleasing than this one, just based off of my imaginary model that I have in my neural network. It will select the best map out of this population, pair it up with a user level from the same tile set, post it on Twitter, and then Twitter will vote on which map they like best, A or B. This information is fed back into the prediction model, knowing, okay, I understand now that the A map was better than the B map. This is more aesthetically pleasing. I'm going to try to evolve maps to look more like A. So from this whole system setup, we ran it for about a year. These are the poll results after about 2 months. So in that red line, as it's going down, you can see that actually the user votes were getting less and less votes over time. So this meant that the model was actually learning to make more aesthetically pleasing maps so that we're able to compete with the user-made maps. And even with the number of votes over time, people were still constantly interacting with this Twitter bot. There were always people voting on these polls, and there was never less than 3 votes at a time. So people were always saying whether or not they liked the map. And we got a lot of submissions from people too for the different types of maps across the 5 different tile sets. And after a whole year, we had a total of 935 user maps and over almost 2,000 polls with votings in them. So users posted a wide variety of different maps with different types of aesthetic that the aesthetic bot tried to learn and incorporate all at once. So the first type was the levels that we expected to see from users, maps that looked like they came from the video games themselves. So such as Pokemon or Zelda or Pac-Man. They actually look like they came from the game. But people actually learned to kind of hack the tile sets and make like even more complicated images with just the same 16 tiles. So making like a stacked house or making a interspersed forest or interconnecting knots in Pac-Man. And then lastly, people made what we call ludic maps. So these are maps that didn't look hacked or like they came from the game itself, but they did look like just other images such as a duck or the word hi or a face. They still look very aesthetically pleasing. There's in particular a user named Niflis, who is the developer of Knit, and he made a lot of aesthetically pleasing maps that were very complicated, and they outvoted a lot of the other maps 94% of the time. So this was extremely hard for the AI to try to learn to make to his level of aesthetic. The AI was also able to learn trends over time from these user maps that it submitted. So for example, with the Pokemon map, it learned that this map was very aesthetically pleasing and even tried to replicate making this weird little house structure in its own generated maps. For the Among Us maps, it learned to group sections of Among Us crewmates together because apparently that was aesthetically pleasing. And then for the dungeon, it also tried to make like these maze-like structures because that's what it learned that people like to see in their dungeon maps. It learned trends over time too. It didn't just stick with the same aesthetic style. So in April, it was really into houses. May, it started putting flowers everywhere. June, it was going through a water phase. July, it started putting paths and fences all around. And then August, it put a lot of trees around. All these were fairly aesthetically pleasing, but also reflected the trends of the users. So it was able to grow and change over time based on user preferences, and it never remained stagnant in its aesthetic evaluation. All right, so we got a ton of data from the aesthetic bot projects, over 900 different user maps. So I'd say it was a success. So what can we do with all this new and exciting crowdsourced data? So there's a lot of popularity with text to image models. It'd be nice if we could actually use these text to image models in game design. So there's a lot of ways you can generate game assets with these. So for example, this is a concept art for a video game, which looks very nice, but you really can't put it directly in your video game. The same with this world map. It is very detailed and very awesome, but actually trying to put it in your game is going to be very hard and require a lot of effort on your part. You can also make sprite sheets like these two right here, but that also requires some post-processing and like pixelization to actually put it in your game and maybe even animations. So these models also require they're extremely large and require a lot of data to train and refine because they're so general. They're not made for making game assets. It'd be nice if we could have a smaller, but also text prompted generation model that takes less time to generate game content and can be put directly into our video game. So we introduced the $5 model. It is a relatively simple and tiny neural network model that takes in, just like these large generator models, text input prompts and outputs game assets instead. The game assets look like this hexadecimal array, which is kind of hard. It doesn't really look like much. It's definitely not an image until you turn it into an image using the tile sets. It's much quicker and it's relatively the same process as these generator models. The model is so simple, we bet $5 that it wouldn't work. So for getting all this data to train the model, we use the AestheticBot maps that people submitted to the AestheticBot Twitter poll. And we also took small 8x8 Pico sprites because this has a similar setup and is only 16 colors. So we asked users to label this data because it actually doesn't have a description associated with this. And we created 2 websites where people could very quickly just say, hey, what does this map look like? And then put in a description for there. Once we get all these descriptions, we can also augment it using ChatGPT to kind of give some variants of the actual sentence itself. So it's not just a man with a mustache dressed in red, it's a mustachioed man wearing red. From this, we were able to generate a lot of general maps from both the text augmentations and the maps themselves, things that didn't already exist in the data set. So for example, is a pond in the woods, and it actually looks like it is a pond in the woods, or an island of trees in a river. We also tried this for the sprite generator, and it was able to generalize and understand the difference between colors. So you can get from Mario to Luigi just by changing from the color red to green. We tried to apply it to emojis, which it was all right. I wouldn't actually use those if I was texting a friend, but they're interesting. So to prove that this model was actually useful in game development, Tim Marino, who is the first author for this paper, actually made a game demo with the $5 model, which incorporated it so the player could input a new map in real time. So for example, with this, user inputs a grassy field with some flowers, and then almost instantaneously, it makes a new map for the player that actually looks like what the player described, a grassy field with flowers. There's also a beach, for example, and it makes something that looks like a beach. So all this done is instantaneously, and the model itself also only needed a few hundred labeled data samples to take all of this from crowdsourced data. All right, so backtracking a little bit to the Bob Azar project again, we still have one major limitation that we need to address. And this next project is that branch for the Minecraft House Interactive Evolver system. So there was the issue of human versus AI collaboration. And as we can see from the user study, participants still prefer to make the levels themselves compared to using the AI suggestions in the edits. So how do we encourage users to allow the AI to make edits and to facilitate a better authorship balance? So for this example, we use the Minecraft game. So Minecraft has a lot of already pre-made user-defined like houses in the game that it just puts throughout the world. These look great. However, if a user wants to build their own house, it takes a long amount of time. They have to get the resources, they have to design it, and they actually have to place it in the game. So what if we had an AI build the houses instead, but let the users decide which structure design they like best? So this can speed up the design process, and the user will get a nice looking house that they can live in, hide from zombies, and you don't have to worry about spending 2 days making the roof just right. So we're going to generate 3D Minecraft houses, but we needed 2 different models for this. The first model, which is a generative adversarial network, focuses on just creating the structure of the house from a latent vector, which is just a list of numbers that define what the house will look like. So this. The second model is a variational autoencoder, which will paint the same structure binary output of the house and apply actual Minecraft textures on it to make it look more like a house. By splitting up this process, it made it a lot easier for the AI to figure out what the structure of the house should look like, and then what should the roof and the walls look like afterwards. To involve the user back in the generation process, we first show them 6 different houses that they can select from, so an interactive evolution process. From the 6, we take the latent vectors for the houses associated, mix and match them with different parents to make children, mutate the parents a little bit, or sorry, mutate the children a little bit so that they're different from each other. And this will generate a whole new house for us that still looks similar to what the user picked out originally, but it's slightly different and maybe even a little bit better. We pass it through these 2 models where it will make the new structure, it will paint it, and we have 6 different houses that we go back and show the user again. So instead of having the users pick the houses physically in Minecraft in case they've never played Minecraft before and they don't have the game and need to fly around and choose, we actually made a online interface where users could select houses that are rendered in their browser in real time. They're rendered like almost a couple seconds actually. And this generation is done behind the scenes. So the user doesn't actually see them like making these GIFs or like rendering the houses. And it's very quick, very seamless process. So we conducted another user study because we love user studies for this, asking users how they like the interface of this interactive evolver and how they like the evolution process and were they satisfied with the output of the houses themselves. So we asked users to design or pick different structure that they could make, like a regular house, tower, or 2 separated houses using this interactive evolver. Most of the users were able to make a variety of houses on the website, but they had mixed opinion about how well those selections actually carried over into the next generation of houses. But overall, all of the participants mostly agreed that procedurally generating these houses were much faster than having to manually design the houses in Minecraft. And they were also, like the Bob Azar participants, interested in more human AI collaboration for creative design. All right, we're going to be taking a little detour from our regular scheduled content generation and introducing a more new abstract form of content generation. So say you're designing a new game, maybe it's for a game jam, and you come up with some concept, it's just a sentence, very short and sweet. And then you come up with what kind of features you want for the game, and you draw a thumbnail sketch, and then you actually build the prototype for the game. So like in this example, you polish it, you flesh it out, and you can turn it into a real game, all from this original concept of just one sentence. So this game development process of going from concept, design, prototype, and polish, PCG or procedural content generation usually sits in this level, making the assets for you or adding the levels in your game itself. But what about giving content and suggestions for the conceptual level, where the game has even barely been conceived of? Can AI assistants help here and not step on the developer's toes by making content that they end up not using in the game? So we will train a conceptual generator model to recommend and suggest new game features based on the game content. So we take training data from the summaries of all the games on Steam. Most of them already contain descriptions of the game features and themes that the game has in itself. So Dwarf Fortress, there will be dwarves and there will be fortresses in Dwarf Fortress. You can build a fortress, you can help your dwarves, stuff like that. We fine tune a GPT-2 model, which is like a baby version of ChatGPT, on these features, entities, and different tags of the game so that when we pass it a list of nouns and a list of genres that we want from our game, it'll give us these same game features or something slightly variant from them based off of this training data. And we also use ConceptNet, which is an online semantic network where you can just pass it a noun and it will give you something similar to game features, such as a pirate. You can board a ship, you can sail a ship, you can find treasure, very similar to game features. We ran yet another user study to test the preference of features across 6 different games. 3 of these games come from real games of Dota, Team Fortress 2, and Breath of the Wild, and 3 games were games that have not existed yet. They were completely made up. And we made 5 human features for each of those 6 games, and we came up with 5 GPT-2 fine-trained features from the model that we made, and then we got 5 features for each game from the ConceptNet. The order of the feature groups were anonymized, so we didn't tell people again which one was AI made. And we performed another user study asking people which one do you like better, based on this sentence at the top. So overall, participants preferred the human-made features for the fake games, but the transformer features slightly outvoted the human features for the real games. Participants also noted that some features from one set and some features from another that they liked and preferred, so fine-tuning the GPT-2 model could lead to more comparable performance. We also want to note that the fine-tuned output had more variance and specificity to the actual game content than ChatGPT's more generic output. So you can still use ChatGPT for getting game features, but maybe our model would be a little bit better for people. Getting into that was a really fun experiment with language models. Can we push them even further for collaborative capabilities? So we've seen AI used for creating new content and evaluating content and recommending game ideas, but can it do all 3? Can it make a whole game for you? So if we pair a human game designer with another game design partner that's either human or AI, it's a mystery. They build a game together. What is the quality different and the difference in quality of the game that's built by either the human and the human or the human and AI? And can LLMs operate effectively at each level of that game design process as an effective collaborator? So we asked ChatGPT to kind of act in multiple roles. We, as the authors, were the human game designers being paired up with ChatGPT. So we asked it to recommend to us game features for a particular game we're working on. And it said, hey, you should add a freeze ability. So then we asked ChatGPT, can you give me code for this? Because I don't know how to code a freeze ability. I am a new game designer. And we'd also allow it to have some bug fixes because ChatGPT is not the best coder either. Then we can ask it, how do we add more game feel? How do we make it more immersive? How do we make it look better to the player? It would give us suggestions for adding game feel, such as particle effects. We asked ChatGPT, can you explain this part of the code? Because I really don't know how to code. And it would explain why it added these variables. It would document it for us. And then finally, after this process of asking for a feature, code, and game feel, we implemented that feature directly into our baseline game. So we conducted another user study to test this methodology of the communication between humans and AI. And we did this for 3 genres of games: an arcade space shooter, a regular platformer like Mario or Sonic, and then a roguelike game, which is turn-based and in a grid world environment where the player has to get a key and escape the dungeon without getting killed. We did this for, we made 3 different games for each of these 3 genres. A baseline game that had no additional features and was just the bare bones gameplay. A second game, which was with human designers for a feature generation, so no AI involved. And then lastly, the ChatGPT feature suggestions and the ChatGPT code. So like the abstract game feature recommendations experiment, we hid the identity of the authorship for each game and asked people, which one do you like better? Rank it based off of these 6 categories: overall preference, game feel, innovation, thematic cohesion, interesting abilities, and visual presentation. So we found in the user study that the human design games were preferred by participants across almost all of the game categories. However, we will note that the ChatGPT design game outperformed the baseline game. So having some features will be better than having no features whatsoever. From this, that we can note that the features suggested by, it did improve the game quality of the baseline game with ChatGPT, but not as much as a human. So as we, the designers and authors for working with ChatGPT for this experiment, we kind of reflected on the collaboration process. Concerning game genre, ChatGPT was great for game themes that were very common, like platformers. But for something that's a little less common, maybe like a werewolf game, how would ChatGPT perform then? Would it give you the same high level quality of game features then? For the game engine itself, we implemented these games in Unity 3D, which is a very well-known game engine, has a lot of resources online, lots of code snippets too. But for something that's a little less familiar like HTML5, how would it do then? Or even something that doesn't have a text-based interface like Scratch, how would ChatGPT have given code suggestions or even game engine suggestions for game feel then? And then finally, for the design phase, we found that ChatGPT was better for giving you good ideas and conceptual inspirations, and kind of acted like a muse. But for more practical things like code, that's where often had bugs, and it couldn't adapt to the context of the base game's requirements. So overall, ChatGPT's performance is contextual, but it's very good for abstract design and inspiration. All right, so this is another background project to provide context for the most recent project in this thesis. I'll be quickly skimming over the results of this, but they set the stage for this final bookend project, the Amorphous Fortress. So in the past few projects that we've seen for content generation, we've seen it apply to well-established game engines or domains. So Keke AI is based off of real-world games like Zelda. We have Baba Is You, which is based off of Sokoban. We have Minecraft, which is a little bit more open-ended in its crafting, but operates in a grid world space. So you're just placing blocks, almost like Legos. So what about domains that aren't as consistent or predictable with their mechanic space? So a game like Dwarf Fortress, where it has emergent AI that exhibits sometimes weird and unexpected behaviors that can't be predicted by AI models for training. Like it might go to war. You don't know how that happened, but it's very interesting, and an AI can't really do much about that. Or The Sims, which allows for different NPC personalities and also with its crafting in the different space design of the houses itself. Or the game ZZT, which allows users to take the base game of ZZT, which was an adventure game, and turn it into an entirely different genre game using the same source code. So this is now a narrative-based role-playing game. So how do we design and use domains that are more open-ended, but also diverse in theme for AI content generation? So this is the Amorphous Fortress framework. It is inspired by both Dwarf Fortress and Keke AI to create emergent but abstract AI agent interactions in a constrained environment. So with this GIF, you can see that the agents and the entities that are moving around in the fortress are controlled with things called finite state machines. So these are very accessible and very explainable AI behaviors where we'll perform an action and then move to doing a different action based on its environment. So like the Keke AI framework, you can use the Amorphous Fortress framework to recreate a lot of different games, such as Sokoban or even Zelda. You can have Link touch a Korok and get a surprise, just like in Tears of the Kingdom. So the agent graphs are defined with 10 different action nodes. And these are common game mechanics such as moving, pushing, adding, or taking. And they're connected with conditional edges that allow them to transition between the action states. So with this definition, you can recreate player and NPC character behavior such as Link in the Amorphous Fortress with just this set of 10 nodes and this 5 set of edges. So we started this framework with a very simple evolutionary experiment to see what kind of emergent behaviors we could get out of the framework. And it was focused on trying to evolve a fortress environment that had diverse and emergent AI behaviors that were very large and had complexity. So with this, we did get very large defined agents, but we also got very small ones. Why? Well, we found that this kind of created a symbiotic relationship. So think about a cow needing grass to survive. And this allowed the agents to actually support itself or turn into other agents entirely. So having a cow next to grass will turn it into a horse. This also created environments where they would kind of explode in population just because they wanted to explore themselves so much. So it actually overpopulated the maps very, very quickly. So now we want to find different environments with different behaviors. So we use the Mech-Elites algorithm again and define it by these 3 characteristics. How many nodes are defined for the agents, how many entities are at the end, and the entropy. How different are the sizes of the agents? Is there a lot of grass, or is it just a bunch of cows, or is it a mix? And because of this, we got a lot of different fortresses that had different behaviors. Some of these emulating things you might find in an actual ecosystem, like things going into extinction or overpopulating, or having an equilibrium where some agents would overpopulate and then die off, and then others would grow. So we found these emergent behaviors from exploring these, just letting the Amorphous Fortress evolve in this environment. All right, very last project. Coming back around to the beginning, we've gone a long way from Babas, y'all, but this project kind of goes back to our roots and puts everything that we've learned together in this. So we've shown that the Amorphous Fortress is capable of creating a large diversity of abstract environments, and it can create a whole different range of AI behaviors and interactions, whether intentionally made or not. So how do we give them more concrete and semantic meaning? I mentioned the cow and grass scenario, but it really didn't have that explicit meaning of cow and grass. It was just an amorphous entity. So if we take the elements of Baba's All system where users can design their own environments and upload them, this results into creating an amorphous Fortress system that is similar to ZZT, where users will take the base game and make their own games out of it and put it online. But also back to Legos, where people can take their favorite characters, the agents in this example, and mix and match them and put them in different environments and new sets to have entirely different behaviors. So now you can put Link in Sakaban, or you can put a cow in a desert if you really wanted to. So with the Amorphous Fortress engine, people can make new games and simulations with original themes, such as a wizard pondering an orb to transform frogs and toads and newts, or a game about a kid exploring a haunted house and trying to stay away from ghosts. You can also use real world themes too in the Amorphous Fortress. So you can recreate Twilight in the Amorphous Fortress. You can have Edward and Jacob fighting over Bella. You can recreate Scott Pilgrim. So Scott fights the evil X's in Amorphous Fortress. You can really have this huge creative freedom with the framework. And it opens up the possibility for new AI environments that aren't limited to mechanics or interactions. So the Amorphous Fortress online website allows users to design their own AI characters with a drag and drop system similar to Scratch, but also place the agents in their fortress and give them names and notes and descriptions to provide some kind of semantic meaning and functionality to these ASCII characters in the environment. Similar to the Baba's Y'all system, users can play the game or simulate them in real time in their browser and see how the agents are actually interacting with each other. But they can also view how the agents are thinking with the X-ray vision, which will show when an agent is changing its state and doing a different action altogether. So this format is very similar to like a classic roguelike, except you get to see behind the scenes for it. So with this online system, users can share and upload their Fortress environments to be remixed and made into entirely different simulations and games from using the same characters. And you create this lineage of almost levels from the Fortress environments. But like the Lego sets, users can also save agents from the Fortress environments, put them in a backpack system, and use them later in development of new fortresses. So you can have Link in a Sakaban environment. So this creates an open but systematically relevant relationship between the characters and the environment altogether. Like the previous system, there exists limitations with the website. So since its release, I haven't been a lot of people submitting fortresses. That might be because it is a very high learning curve to use this framework. It is completely new. It's not like working with Baba's U or Mario anymore. This is an entirely new system. So ironically, this limitation could be alleviated with AI assistance. So by having a mixed initiative system where AI will help you design your fortress based on a text, like I want Scott Pilgrim as a fortress. Maybe we'll figure out that relationship between Scott and how he acts, or like Ramona and the evil X's, and allow you to make a fortress with this AI incentive. So now people want AI to be used in their content creation again. So last but not least, some conclusions. This is to prove I actually learned something these last 5 years and wasn't spending the whole time playing video games. Just as a refresher, this is the main thesis of my research work. When applied to creative domains, online systems allow users to more effectively design, share, and evaluate content with AI tools. And I talked about 10 projects over a span of 5 years, but what's next? For future work, I want to make more text to blank systems. We have text to image and text systems already. What about text to levels and text to fortress environments and text to video games? I think that's the next step for all of this work. More user studies, because I love user studies, they're great. It's great for measuring effective communication between AI and human systems. Do humans actually want to work with AI, and how well do they work with AI? Using all this online data that's collected from both the AI and human collaborations into more extensions of AI projects. It's fantastic next step. And then finally, using AI online collaborations for different aspects of gameplay. So not just making levels, not just making sprites, but helping you to make video games entirely. And overall, some reflections. Collaborative AI systems can be very helpful when they're used in the right context. So when you need an AI, do you need it for giving you inspiration, or do you actually need it to make things for your video game? Online systems also provide a lot of accessibility to these AI systems. You don't need a supercomputer and you don't need a PhD to use AI anymore. You can do it on your browser or on your cell phone now. And overall, facilitating better user AI collaboration is still a work in progress, but the things that we make with human AI collaboration is incredible. It's very novel and innovative. It's better than what we can make on our own or what an AI can make on our own. So thank you. That's it. Thanks for all. All right, now what? Okay. I don't know how to get, oh crap. Okay, hang on. questions from the audience. I went through that so fast. Let's see. How do I get back to the Zoom? Oh, I stopped sharing. Okay. Cool. Questions from the audience.
How did they get to that?
That's a great question. So yes, how did I get my Twitter audiences for the aesthetic bot to interact with? I used my own Twitter first and was like, hey, we have a new research project, except you can actually use it on Twitter. And that immediately got people to working with the website. So it started off with just people in the games AI community that were, of course, naturally interested in games and AI, but you retweet it, it gets spread out, and then people will follow the account. And because they follow the account and the bot is constantly adding new content, it was very easy for them, just even when they're scrolling through Twitter and forgotten about it, to just say, oh, the aesthetic bot, let me vote real quick and then go about my day. No, not at all. It was absolutely, yeah, you probably should have used that. Oh man, I should have thought. I would have made it way faster. Yes.
So when it comes to studies, personas and play styles, typically come in as part of that. How the different types of players engage. Do you think that there's, I guess you've already thought about this. Great. Curious on it, but if you wouldn't mind now sharing, do you anticipate that there are different groups of users that would engage with AI systems like this, online systems involving AI, and how do you think that would?
So the question was what I anticipate different groups of people working with AI in different contexts or different ways, depending, or yeah, absolutely. And that's a common thing that I found with the user studies too. I didn't include it in these slides, but we always ran a demographic survey about the users that were interacting with the systems. For example, with the Baba Azal system, we asked players like, hey, do you like puzzle games? Do you like designing things for video games? And that definitely will make a difference of like whether or not they're going to like a puzzle game where they have to design things. The same with the Minecraft interactive evolver. When I play Minecraft, I hate building stuff. So might even enjoy having an automated system do it for me versus somebody that actually likes doing the creative process of building something. They may not want an AI to interact with it. So I think one of the very key things of doing a user study and making these new AI human collaboration systems is asking people, do you want this and how are you going to use it if this is helpful for you with whatever you're trying to do? I hope that answered you.
No, I mean, what the question is, I think we're talking about aesthetic stuff. There's something that Julian does, so I was interested just even that's of different types of aesthetic.
Absolutely. And you see that with the voting system too. Like sometimes you'd see a terrible looking map and people still vote for it just because it's like it's very niche and they like it. Like, but yeah, I think that was also like a limitation of the system too. It tried to learn one aesthetic, which does not exist apparently. Like there are multiple types of aesthetic and it tried to combine it all at once, which is not ideal. So if I redid that project, I think I would try to figure out how I could define different types of aesthetic using like that level and hacked and ludic system maybe. And then the AI could maybe learn to make specific types of aesthetically pleasing looking maps instead. Extend the project, exactly. These can all be extended for sure.
Yeah, the next one.
Next PhD, yes.
For your students.
Definitely. Apparently I have my camera off the whole time, so sorry about that on Zoom, everybody. Yes.
So across all the different kinds of collaborative systems you did, and kind of going forward, I'm curious about your thoughts between the different ways that you kind of solicit this input from the user. Because like one way that you kind of alluded to is like kind of code lists, like just let the language model or some kind of underlying system go from just how the people are speaking naturally to code. Another way is kind of Scratch-ish, where you're doing the drag and drop system. And then there's also another way where you're actually having to write little bits of code.
Right.
I'm curious what you feel about like the relative advantages and disadvantages of the systems. You're trying to make something online.
So to summarize the question, what is my reflections on like different ways people can communicate with AI systems as they're working to develop content generation? That's a great question because ideally you want to be like, for an AI to learn the best, they want a user to be as descriptive as possible, like having entire text like saying exactly what they want, very, very detailed. A user doesn't want to do that. I don't want to do that. So you have to have this balance between like making something very easy and very accessible that doesn't take a lot of effort to do in the first place, but also making sure the AI can learn enough to refine it to what the user wants. So it's kind of a, you have to do this thing, but it's going to take a lot. So do you actually want to do it? I'm trying to, the aesthetic bot system, I think definitely tried to address that issue of like, users don't want to put in ratings and actually have to play the video game themselves and then decide whether or not it's harder or not. So how do we kind of remove steps and gradually get them into putting as much effort as possible into it? So it's a lot easier when you can just design a map on your cell phone and then go about your day versus when you have to stop, sit at a computer, play a video game, and then say how good or not it was. So yeah, I think going forward, I want to explore different modes of communication that is both easy on the user, but helpful for the AI. Yes. Mm. Yes, definitely. So the question was how to get more user involvement and get more samples for the AI to learn from this data. And is that, does that, okay. Mm. And following up, designing a project to attract more people to use a system. Yeah, honestly, that would be the ideal project for me. Something that is both engaging and that people want to keep interacting with the same way they would a video game, but also like that an AI could get a lot of data out of and a lot of data samples. So it goes back again to that balance of like how much effort does a user have to put in that is also fun for them and engaging versus like they can just do something really quick and go about their day, which is not a lot of data in the first place. So the aesthetic bot data, I think, got the most data, but that's because it was required the most minimal effort from a player or from a user. Like they just vote in their Twitter page. It takes the same amount of effort as liking something on their Twitter page. It didn't get a whole lot of data out of it. Well, it got a lot of data out of that, especially from the people that actually went in there to design different levels. And it was very, I think accessibility is the key here. Like if your system is not accessible enough, not enough people are going to use it. So if you have a system where it requires you to have like a supercomputer, like if you want to get involved with using text to image generation with like DALL-E 3 or Stable Diffusion, and you need 3 GPUs, like not a lot of people are going to be able to use it versus something if you have in your browser or on your cell phone, it's much easier and you will get, without a doubt, a lot more people involved in interacting with your system. So I think the key here was online systems, I think, can help facilitate getting more data and more engagement from users. Yes.
Balance between getting minimal effort, but also getting maximum input.
Mm.
Seems like something you actually use the ChatGPT style prompt, where if you give someone okay, they can put sentence versus text. The AI elaborates on that and just asks, is this yes or no? Does that seem like something that you could explore?
Definitely. The key thing with ChatGPT though is like it is a large model, and I am not OpenAI, unfortunately. So in a perfect world, researchers and students would have access to these large and be able to develop these large language models that are very general and can fill in the blanks a lot better than their own systems. But I think me as a researcher, I want to focus on making things more accessible and smaller, but also can still go a long way. I like ChatGPT, but it's so very general. And if I want a very specific tool, like for game design, if I want, hey, I need a specific level, I don't think ChatGPT, I would need a lot of communication with ChatGPT to get it to exactly what I want. And even with the ink splotch problem, it was getting interesting results and was getting code for us and was getting game features. But as it got more and more down the pipeline, got more specific, that's when it started losing its effectiveness, essentially. So there's still a need for these large language models that are very general, very accessible. It's kind of like introducing people to, hey, you can do this with AI, but there's still also a need for these smaller models that are more accessible to researchers and for people to develop to make even better, if that makes sense. Thank you. Is it? Yeah.
Text,
Mhm.
like the text.
That's a good point. I like the blank to blank because that could be like change this map into something else, or like style transfers. Like I want to go from this genre to this genre. I think that could be very interesting too. Text to me is the best way to communicate, or like it's language. We all use language to communicate, and we're still trying to figure out how do we best communicate with AI that it understands us the same way a human would understand us as if we're talking to it. So I think for now, like text to blank is still the best way to try to get new content that is also directly with what we want to communicate. But blank to blank would probably be the next step after that of, yeah. So the question was, would Amorphous Fortress, sorry, Rafa, would Amorphous Fortress be a good input for like this fortress to blank, like a game model? I think so, yeah, because it's such a small representation of essentially a video game. So it would be nice to transfer the Amorphous Fortress into an actual video game, like in step by step, either in Bitsy or like a small fantasy engine or in Unity. So yeah, that's really interesting. I didn't think about that. I like that. Thank you, Tim.
Okay. So now, sorry, I just wanted people on Zoom to hear me as well. So I suggest we give Em another round of applause. They deserve it. I mean, for reference to people on Zoom, we have about 25 or 30 people or so here, and another
Full house.
yes, yeah, it's just like room is packed, and another 15 or so on Zoom. Okay, so now we're entering the next phase, which is we kick all of you out. Those of you who want to stay on, which I suggest you do, you will go down to room 610 on the 6th floor. That's the Game Innovation Lab. Wait. So people who are in the Game Innovation Lab will be able to show you there. There's like a bunch of you here, including Maria sitting next to me. And once the next phase is finished, we will arrive down there. So next phase is that the committee, including me, Wes, Antonis, Kate, and Mike, will be asking questions in private to Em, and Em will answer. So great. Thank you all for showing up, and hope to see you all in an hour or so.